we've done all the transformations, we started off with looking at the translations. So vertical, horizontal, left, right, up, down. We've done the reflections, and the only reflections that we've done is across the X and Y axis. Can you reflect in other axes? In fact, we're going to find out today that you can reflect in another axis. Another axis of reflection we're going to talk about today. We also talked about stretches and compressions, vertical stretches, horizontal stretches, vertical compressions, horizontal compressions. And then we looked at how we can combine all of these different things together. All right. Now we're going to talk about an inverse. It's a kind of a transformation of a sort. And I'm going to describe it this way. Inverse of a function is a set of ordered pairs obtained by interchanging the x and the y coordinates of the ordered pair. So x becomes y and y becomes x. They do a bit of a trade, is what we're saying. To graph the inverse of a function, it can be illustrated on a graph as a reflection. We just mentioned the word reflection. It can be illustrated by a reflection on the y equals x line. So let's see what that looks like on a graph. What I'm going to do is, what does it mean by reflecting it on the y equals x line? I hope you remember from your work in grade 9 what the y equals x line looks like, right? It's a straight line. Like y equals mx plus b is a straight line. The slope of the line y equals x is 1. The intercept of it is 0, so it goes through the origin. And all that happens on the y equals x line is that every x and every y is the same. So the point 2, 2 is on the y equals x line. The point 5, 6, 5, 5 is on the y equals x line. Minus 3, those are all on the y equals x, because every y is equal to every x. So let's take an example, not of the y equals x line, but the 2x plus 1, and let's also come up with this inverse. All right? So here we go. I'm going to write down the table of values for the 2x plus 1 line, going from minus 4 to 4 in only even numbers. Okay? So that would be minus 8 plus 1, which is minus 7. Minus 4 plus 1, which is minus 3. This would just be 1. Then this would be 4 plus 1, which is 5. I'm going up by 4, if you notice the trend. 4 2 is 8, and 1 is 9. So that would be a table of values for a straight line that has a slope of 2 and has a y-intercept of 1. Right? That's typical y equals mx plus b stuff. But what is its inverse? Well, one definition of the inverse is to just simply reverse the order of these coordinates. So instead of minus 4, 7, it's minus 7, 4. Instead of minus 2, minus 3, it's minus 3, minus 2. Instead of 0, 1, it's 1, 0. Instead of 2, 5, it's 5, 2. Instead of 4, 9, it's 9, 4. It's that simple. It really is that simple. Yes. It would be minus 4. Thank you for pointing out that error. Absolutely. Right? Because if you're reversing them, they're not going to change sign. All we're doing is changing where they are. So yes, Che is right. Che is good at spotting when I make these errors. Very good, Che. All right. So what does it look like on a graph? Well, let's go ahead and draw both lines on the same graph. Minus 4, minus 7 should be somewhere around, let me get a different color for this. So minus 4, minus 7, I'm going to say is here. Minus 2, minus 3 should be about there. 0, 1, 2, 5, and 4, 9. So I'm going to go ahead and try to put a line through all of those points. All right. Is that what, sorry? That's 4, that's 3, 9. Yeah, you're right. I wonder that last point is not working. Thank you. So let me erase that last one. 4, 9. Right there. Okay, that makes it much better to try to put a line through that. So that's approximately what that line looks like. So 2 goes through the y value of 1. But what about its inverse? Well, we said that it is a reflection on the line y equals x. And we also said that all we need to do is to flip these two around. So we're going to do that. I'll put that in a dotted line with a different color. Oh, well, first of all, I need to put the points on. We'll put the points on in green. So minus 7, 4. Minus 7, minus 4, that is. Right there. Minus 3, minus 2. Uh, 1, 0. 5, 2. And 9, 4. Okay. And let's try to put a line on that. Maybe a dotted line for the inverse. So it's also a line. Actually, this line could use a little work. Okay, there we go. And before I hear anything from anybody, let me put some arrows on these lines. Okay. Now I'm also going to put in the line y equals x. Right? I just mentioned that line to you because I'm saying that this black solid line is a reflection. Actually, the black dotted line is a reflection of the line I put in before across the line y equals x. I'm going to put in the line y equals x so you can see what that looks like. So I'm going to put that line in, put a few points in for the line y equals x. So 5 and 5 would be on that line. 5 and minus 5 would, or minus 5 and minus 5 would be on that line. It goes through 0, 0. So that line should look something like this. It's a very, in this case, a pretty thick line. Every single point on one side of this line is reflected across to the other side of the line. Remember, a reflection takes a point from one side of the line to the other side of the line. So this point ends up on this side. This point ends up on the other side. That's what a reflection does. It takes the point on one and puts it on the across on the other side of the line. And that's why the y equals x line represents the axis of reflection. Just as how we could reflect across the x-axis and reflect across the y-axis, we can reflect across the y equals x line if we're looking for an inverse. Okay? All right, you're probably going to be wondering, so how about the equation of the line? We're going to get to that. How do we find the equation of the inverse function? We're going to get to that. We're going to try this again. We're going to graph y equals x squared minus 2 and its inverse by first of all coming with a table of values, flipping those tables, the coordinates in the table of values, and then drawing the line. Okay? So x squared minus 2. Let's put minus 3 into that, minus 2, and so on and so forth, and see what that looks like. We kind of know already. In fact, I could use a table, but I could also use my knowledge about, yes, Jaheen. Pardon me? Okay. Okay. Can't zoom much more than that. So that's about as far as I can go. Okay. So what one way that I could draw this, another easy way to draw this, is to recognize that I know where the vertex of this line is. Can anybody help me where the vertex of this line is? The line y equals x squared minus 2. Where is that? Because it's kind of vertex form in a sense, yes. 0, negative 2. Because you might think, doesn't it need a bracket for vertex form? Well, in a sense, you could say this is x minus 0 squared, which is just x squared. So 0 minus 2 absolutely is where the vertex is. So I'm going to go ahead and put the vertex on there in, let's see now. We'll put that on there in red. Minus 2 is where we're starting from. Right there. So 0 goes to minus 2. Across 1 up 1, across 1 up 1, which means that at 1, I should be at minus 1. And the same thing for that. Now, let me just double check the math on that. So that should be minus 1 squared minus 2, which is minus 1. Yeah, that's fine. Okay. Across 1 and up 3. So 1, 2, 3. Across 1 and up 3. 1, 2, 3. So that means that at 2, I should be at 2. And the same thing here. Does that make sense? That would be 4 minus 2. Yeah, that's right. And then when I'm at 3, across 1 and up 5. 1, 2, 3, 4, 5. I'm at 7. That makes sense. Okay. All right. So, I mean, we could have done the actual algebra and just plugged in these values. Minus 3 squared is 9, 9 minus 2 is 7, and so on and so forth. So we could have done that. But it's more fun doing step pattern, I think. All right. Let me join these up. Nice smooth line or curve or whatever. No, that's not a nice smooth anything. So what do you think the inverse might look like, right? Any clues, any ideas as what the inverse might look like? Right, I'm about to draw it. Yeah, we're going to draw it. But do you have a sort of an inkling for what it might look like? What kind of function do you think it might be? Right? Okay. Shamin, you had your hand up. What do you want to say? If you think you might know, what do you think? Yeah, we're going to switch them. That's true. You're absolutely right. So we do the inverse. But do you have some kind of an inkling for what kind of function it might look like? An inverse of a quadratic. What do you think it might be? What do you think the opposite of a quadratic, well, not so much the opposite, but the inverse of a quadratic might look like? Yes. It does. In fact, it's kind of looking like a square root function. If you think of a square root function, it looks like that, except it's going to be both sides of the square root function. It's the plus of the square root function. So you're right. Okay, Nakib is absolutely right. So let's go ahead and put the points in, like we just heard from Charmin. Instead of it minus 3, 7, we're going to have 7 minus 3. Instead of minus 2, 2 is going to be 2 minus 2. Minus 1 minus 1. Well, somehow that's going to stay the same. There's a reason for that, which we're going to talk about in a minute. 0 minus 2 is going to become minus 2, 0. 1 minus 1 is going to become minus 1, 1. 2, 2 is going to still be 2, 2. And this is going to become 7, 3. All right, so again, I'm just flipping the points. Just flipping the points. Let's put this together on the graph in a different color. So let me use, let's see now, we'll use purple for this one. 7 minus 3 is somewhere down here. 2 minus 2 should be so. There's a way to use a step pattern for this as well, except it's the opposite. Instead of going across one and up one, you're actually going to go up one and across one. But, well, I'll just put the points in. 2 minus 2 should be here. Minus 1 is here. Minus 2, 0 should be here. Oh, I'm doing something wrong. 7, 3, 2, minus 2, minus 1, minus 1. Yeah, okay, that's fine. Minus 2, 0. I put 1 and minus 1, didn't I? Yeah, minus 1, minus. Okay. Yeah, you're right. Thank you. Got to get it right. So minus 1, minus 1 is here. Okay. Did I put the other one right? 2 and minus 2. 2 and minus 2, and then minus 1 and minus 1. Okay, fine. Minus 2 and 0 should be here. That's 3. You're right. Then on the other side of that, I have minus 1, 1, which is here. And then this one should be here. And then the last one should be here. So here comes my graph. Inverse notation is written as f to the minus 1 of x. So the exponent of minus 1 beside the f means I'm looking for the inverse function to the one I had before. And it's read as the inverse function of x. So the inverse of a function is not always a function itself. So in the one that we just did, the quadratic function, that's a function. It passes the vertical line test. But the inverse function, you notice that it had that kind of a C shape, that would fail the vertical line test. So the inverse of a function doesn't necessarily have to be a function itself. Y equals x squared is a function. The inverse of that is y equals plus minus the square root of x, which is not a function. Domain and range will also switch. So the domain of the function would become the range of the inverse, and vice versa. The range of the function would become the domain of the inverse. So if you were given a function and were given the domain and range of that function, then you are asked the same thing of the inverse function. All you need to do is swap those two things, because that's really what happens with an inverse. You're swapping the x's with the y's. So you're also swapping domain and range. For example, here's an ordered pair. You know, I can give a function as ordered pairs. There's 2, 0, 4, 1, 6, 2, 8, 3, and 10, 4, right? Let's find the inverse and state whether the inverse is a function. So what would the f, let's write it over here, what would the f to the minus 1, actually erase that. What would the f to the minus 1 of x equal? Well, we have our coordinates that represent the function. We just have to come up with the swap, which is 0, 2, 1, 4, 2, 6, 3, 8, and 4, 10. Now, we should ask the question, was the original thing a function? Well, it was, because every single x value was unique. 2 went to 0, 4 went to 1, 6 went to 2, 8 went to 3, 10 went to 4. But is that true of its inverse? Is that also a function? In other words, is every single x unique? What do you say to that? We talked about what makes a function before. Look at those. Would you say this is a function or not? The inverse, that is. Is the inverse also a function? Thumbs up from, I think that's a thumbs up over there from a, excuse me. I think that's a thumb. Does everybody agree that that is a function as well? Okay, let's try this for the second one. The h of x is these coordinates. And that is a function. So the inverse is a function. So h to the minus 1 of x, the inverse function, would be 6 minus 3, 4 minus 1, 2, 1, 0, 3, and 2, 5. So that's the inverse. Now, I'm not saying whether it's a function or not. I'm saying it's the inverse. Is it a function, though? Is it also a function? Sarah says no. Where it fails the test of function is when you look at the fact that 2 maps to 1, but 2 also maps to 5. That means that it cannot be a function. You cannot have an input linked to 2 different outputs. So that's why it's not a function. So let's put a note under here, not a function. Whereas this one is a function. Finding inverse of a function algebraically. So I mentioned this before. You can actually find the inverse without using a table of values. It's a very simple process. Let's take this function, g of x function. So g of x is equal to 2x plus 3. So remember now, anything I put in this g of x function gives me some kind of output. I put a 6 in, I get some number. 6 times 2 is 12 plus 3 is 15. Is there a function that would do the opposite of that? Because that's what inverses do. Inverses reverse the direction that the function takes you in. So if a function takes you from here to here, then the inverse function is going to take you from here back over to here. Okay? So what kind of function would that be? Well, here's the way that most people come up with the inverse functions. They first of all, they traded the g of x to make it just simply y equals 2x plus 3. And then they actually swapped the x with the y. So instead of saying y equals 2x plus 3, they would say x is equal to 2y plus 3. All right, I put on the side here, swap. X and y. And then I'm going to isolate the y. So x minus 3 is equal to 2y. And I'll put the same thing over here, that 2y is equal to x minus 3. And then obviously, if I'm trying to isolate y, I'm going to divide both sides by 2. So y is equal to x minus 3 divided by 2. This is my g to the minus 1 function. G to the minus 1 of x is equal to x minus 3 over 2. Now, how do I prove that? Easy. Let's take a value and put it into the original function. Here's my g of x function right here. Right? I used the number 3 a while ago. Pick any number for me, please, Sahil, between 1 and 10. I want to make it relatively easy. Any number between 1 and 10. 9? 10. Okay. Let's find the g of 10. This is just the proof over here. And we use Sahil's choice, but it will work for anybody else's number. So the g of 10 would be equal to 2 times 10 plus 3, which of course is 23. All right, agreed? So I'm going to ask the question, what would the g to the minus 1 of 23 be? Which is, what happens if I put that result as the input into the inverse function? Well, let's find out. G to the minus 1 of 23, we have the g to the minus 1 function right here, should be equal to 23 minus 3 divided by 2. All right, that's my inverse function, right? Here's my inverse function right here, x minus 3 over 2. I'm putting 23, the result of putting in the 10 that Sahil gave us. 10 gave us 23, so 23 should give us 10. Yes. Why is it negative 1? Is that what you're asking? It's just negative 1. Yeah, it's just an equal sign. Yeah. So 23 minus 3 is 20 over 2 is equal to 10. Let's try to find the inverse of this function. Same idea, right? We can do the proof as well, but same idea. Find the inverse of the function f of x equals 3x squared minus 8. So f to the minus 1 of x. Well, first of all, before we get to f to the minus 1 of x, let's start with the way that we did the last one, which is change this to a y. So y equals 3x squared minus 8. And then we said we would swap the x with the y. So x equals 3y squared minus 8. That's where the swap happens. Now, let's go through the process of isolating the y. That's our goal. Then we can put it as the inverse function. Give me the next step in isolating that y, please. Help me out, please. Amira. I'm trying to get the y on its own. Yeah, so let's add 8 to the two sides. So x plus 8 is equal to 3y squared. And Athusan, what happens next? I'm trying to get that y on its own. Divide by 3. So x plus 8 over 3 is equal to y squared. Okay, so what happens next? Yes, AJ. Root it, square root it. Yep. But when we square it, we have to take the plus and the minus square root. So we're going to say that y is equal to the square root plus and minus of x plus 8 over 3. So my inverse function, f to the minus, not f, it wasn't f, it was something else. It was f, okay. F to the minus 1 of x is equal to plus and minus square root of x plus 8 over 3. That's my inverse function. All right? That is the function that reverses the effect of the original function. Let's prove it. Give me a number between 1 and 10, please. 6. Okay. So here is my proof. I'm going to find the f of 6. F of 6 will be equal to 3 times 6 squared minus 8. So that would be 36. I don't know what 36 times 3 is. Is that 108? 108. Is that 100? Help me out, please. 36 times 3, what is that? 108? 108 minus, I can't do everything in my head, which is equal to 100. So you can double check that, make sure I got that right. So 6 squared is 36. 36 times 3 I hear is 108. 108 minus 8 is 100. That's what I got mentally. But you double check that. Did I get that right? Okay, good. So if our inverse is good, then that would mean that f to the minus 1 of 100 should give me back the 6. Well, let's see what the inverse function says. It's x plus 8, so that square root of, plus and minus, 100 plus 8 divided by 3. 100 plus 8 is 108 divided by 3, square root of that, plus and minus. And 108 divided by 3 is 36. Plus and minus 36, square root, which is, of course, equal to 6. Exactly the number that you gave us when I asked the question earlier on. So there's the proof right there. Okay. Now, let's do a few more questions before we can't give you much of a break today. We kind of had a break forced upon us. And I want to get you started on your assignment for today, but let's move on here. Okay. Let's try a few of these and see how we do with those. Find if the function is 7 minus 2x minus 1 squared and x has to be greater than or equal to 1. So we're restricting the domain of the function to values of x which are greater than or equal to 1. And we're doing that because of, well, you'll see why we're doing that in a minute. We're only taking numbers that are greater than 1. Right? Nothing less than 1 is going to be accepted in our domain. So what's the f of 3? Well, that's simple. We know what that is. That's just plugging 3 into the formula. F of 3 is 7 minus 2 times 3 minus 1 squared. Okay. So this is part A. So that's equal to 7 minus 2 times 2 squared, which is 7 minus 4 2's 8, or minus 1. I believe I got that right. 4, so 3 minus 2 is 2 squared. So 4 2 8. Yeah, I believe that's right. So there's the f of 3 right there. What's my inverse function now is the question. Well, we're going to go through the process again, right? We're going to go through the process. First of all, writing it as y equals. I'll do B over here. 7 minus 2, minus 2 x minus 1 squared. And what was that next step again? Just remind me, help me out. What's that next? Yes, man, switch the x and the y. So x equals 7 minus 2 y minus 1 squared. Okay, okay. Give me some help, please. Is teacher struggling? Need help? Need help? Come on. I want to see some new hands here. I see. Thank you very much, JJ, and thank you very much, Suchir. All right. Where's everybody else in the classroom? Classroom has 31 students in it, and I get the same 5 students every single time. Ashton, tell me what's next. Trying to isolate that y. Seven and two at the same time. I think we should do one step at a time. What's the next step? Can't do that. Can't do that because you'd be violating the bedmass law. They'd come and lock you up for that. Can't do that. The bedmass police would lock you up for that. Can't work. Right? You're supposed to be multiplying this by this. So you can't take the 2 from the 7. You can't do that. That's illegal. I'm being overly dramatic here. Yes. That's what we need to do. Okay? Take the 7 from the 2 sides. You can't just take the 2 from the 7 because you can't do subtraction before you do multiplication. This 2 is being multiplied by this. So you can't take the 7 and the minus the 2. So yes, what Che just said is what we need to do next. X minus 7 is equal to minus 2, excuse me, y minus 1 squared. Okay, I'm taking the 7 from the 2 sides. All right, what happens next? Okay, Gary, what do you want to tell us? Divide both sides by negative 2. So we have x minus 7 over minus 2 is equal to y minus 1 squared. Good? All right, I need another step. I need to know what happens next. All right, Suchir, go. Do what? Take the root of both sides. That's good. So the square root of x minus 7 over minus 7 is equal to just simply y minus 1. What's wrong? It's negative 2. Yeah, that's supposed to be negative 2. Sorry. X minus 7 over minus 2. It's not 7, it's 2. Thank you. I don't know how a 7 replaces a 2. Yes, sir. Yeah. Good point. And the thing about this one is that they did say that they don't want this, they have that x has to be greater than 1, specifically because they don't want you to have to deal with negative square roots. That's why they made the domain of the function that x has to be greater than 1. So that the range would also be, because when you do the inverse, the domain becomes the range. They want the range to also be that you can only have numbers which are greater than 1. Okay? You'll see in a second why that's important. Great point. Great question. Great point. Let's keep going. So now we have this. What happens next? This is x minus 7 over minus 2, by the way. I just want to be clear on that. All right? What happens next? Yes. Good. Good, good, good. And we should test out our inverse and make sure inverse is working, by the way. All right? So y is equal to the square root of x minus 7 over minus 2 plus 1. Okay, I hope I did everything right because I know I made some mistakes along the way, but we'll test it out. We'll just test a number and see if it works. All right? Give me a number, please, Sana, between 1 and 10. Any number between 1 and 10. 8? Okay. So we're going to test out our inverse and make sure our inverse works. So this is the proof over here. If it fails the 8, we know it's not good, right? So we're going to find the f of 8 on the original function. The f of 8 would be equal to 7 minus 2 times 8 minus 1 squared. So that should be equal to 7 minus 2 times 49. And that would be minus 98. So 7 minus 98 should be minus 91. Can you check that for me, please? Make sure I got that right. I don't know if I did that right. 7 minus 2 times 49. Double check that on your calculator for me, please. Am I good? Thank you. All right, so let's check that now with the inverse function. So f to the minus 1 of minus 91 should be equal to the square root of minus 91 minus 7 over minus 2 plus 1. So this should be equal to the square root of minus 98 over minus 2 plus 1. So this should be the square root of 49 plus 1. 7 plus 1 is equal to 8. So, 7, sorry, I'm thinking too fast. 7 plus 1 is equal to 8. So it passes that test. Thank you for the choice that you made there. Okay, a few more things. What's f to the minus 1 of 5? I want you to work that out for me right now, please. What's f to the minus 1 of 5? So you have your inverse function. All I'm asking you to do is to put the 5 into it. See what you get. You have the inverse function. Just plug it in, everybody. Put it for themselves. Write down 3116 for me here. 3116. In about 2 minutes, I'm going to ask you to go down to Mr. Brian in that room, okay? Okay, so let me get some answers from you on that. What's f to the minus 1 of 5? Athuzan, you have an answer for us? You've worked this out already? Or work it out for us, because I'm asking you. I've asked everybody, including you, to work that out. All I'm asking you to do is put the 5 into the function. And if you need to see the function is right here. This is my inverse. Oh, let me write another line here. F to the minus 1 of x is equal to the square root of x minus 7 over minus 2 plus 1. Another way we could write that, I often don't like when we put a negative denominator. So here's how I would fix that. It's a square root of 7 minus x over positive 2. That's exactly the same thing. Plus 1. It's exactly the same thing. What's that? You need help. I wish you had said that when I'd asked the question the first time. Okay? Okay, let's come back to this now. So let's put 5 into the function. Here's the function right here. Just plug the 5 into that. Into where, correct. This is my inverse function. And I'm asking you to put 5 into that function. Okay? All right. Right. Yes. You got 2. Is he right? All right. You got some agreement over here. So I'm gonna assume that Krisha says it's right, it's right. Okay? All right. Okay. What does it mean to find f of 2a plus 7? What does that mean? Right? I'm not asking you to find a number like 6 or 5 in the case of what I just asked you to do a while ago. If I ask you to find the f of 2a plus 7, how do you do that exactly? Yes, go ahead, man. You plug it in as x. Jay, I saw your hand up as well. Correct. That's exactly what we're going to do. Into the original function. So, the original function was 2a plus 7, by the way. The original function was 7 minus 2x minus 1 squared. So, 7 minus 2, 2a plus 7 minus 1 squared. So make sure I got everything in there. Oh, there's a 2 in front of that. Yeah, I do have the 2 there. So it's algebra at this point to finish this up. So f of 2a plus 7 equals 7 minus 2. Now remember, squaring comes first. BEDMAS says brackets and exponents. So I'm going to do the squaring first. Oh, by the way, let me simplify this. This is going to be 2a plus 6 squared. 7 minus 1 is 6. I can't put the 2 into the bracket. I have to square it first. So 7 minus 2 times. Now, I showed you a way that you can do this quickly. Square the first term, which is 4a squared. Multiply these two together and double it. So that would be 12a times 2, which would be 24a. And then square the last term, which would be 36. A lot of algebra here. What comes next? Anybody? What happens next? Yes. If I could do what? Sorry? Take out the 7? What do you mean take it out? Just throw it out? Okay, so Athusan thinks we take the 7 and minus the 2. Is that correct? Are we going to do that? What do other people think? Yes. It's exactly the same thing I said a few minutes ago to Ashton. You have to do the multiplication first. That's what BEDMAS says. Jahim, I can hardly hear you. Square the bracket. I did that already. I can expand it. Yes. We're going to multiply that minus 2 into the whole bracket. Got that, Jahim, listening back there? So that's equal to 7 minus 8a squared. Oh, sorry. The telephone call came in. Sorry. How I squared the bracket? Yes, I can. Was that my thing that just dropped? Okay. All right. You square the first term. That's the 4a squared. You multiply these two together and double it. So 2a times 6, which is 12a, double is 24a. Then you square the last term. Okay? So minus 8a squared. And then minus 2 times that is minus 48a. And then minus 72. Yeah, I think, yeah. And then we're just going to tidy things up now. So minus 8a squared minus 48a. And then that's minus 72 plus 7, which is minus 65, I think. Yeah, okay. All right. So that's putting in the 2a minus, the 2a plus 7. Okay. How about putting that into the inverse function? It's simple. It's the same idea, right? We're just putting the 2a plus 7 into the inverse function. Here's my inverse function. Where's my inverse function? It's the square root of, I changed it to this. So all you'd be doing is just putting it in here. And I don't think I want to go through all of those steps with you. I want to move on to the last question so we can get started on the classwork question, right? So the last question is this. The last question I want to do with you is this question. If f of x is equal to this here, some function has a k. I don't know what the k is. Find the value of k if I put minus 2 into the inverse function, I get minus 3. Huh. Let me say that again. Find what the missing k is. There's a function that looks something like this with a k in the front. Don't know what k is, but I got some more information. If I put minus 2, not in the original function, if I put minus 2 into the inverse function, I get minus 3. Okay. Is that enough to help us out? It is, actually. Can anybody think of how that information might help us out? So, Chair, what do you think? But do we have enough information for that, you think? Do we have enough information to, I mean, this is a k. You know, I mean, how do you propose to find the inverse if we're still missing some of the parts of the function. Tell me, good, tell me. So you're saying go through the same process to find the inverse function? Okay, we can try that. Anybody have any? And we can try that. Aaron, what do you want to tell us? Can hardly hear you. Put a negative 3 into the x. Brilliant. Remember that the x and the y will swap in the inverse. So if minus 2 in the inverse gives you minus 3, what that means is that minus 3 in the original function gives you minus 2. Remember that the inverse and the function cause the x and the y to trade places. So the domain becomes the range, and the range becomes the domain. The x's become y's, and the y's become x's. So in a sense, what we're saying is that since in the inverse function, minus 2 gives you minus 3, putting minus 2 into the original function will give you minus 2. That's what I'm saying. So we're saying that the f of minus 3 should be equal to minus 2. That's what we're saying. That's exactly what we're saying. I want to make sure everybody understands what I just said, right? Inverses reverse the direction, right? It takes you from what you put in to the original thing that you put in. Takes you back to the original thing that you put in. So what this means is that if I put minus 3 in here, I should get minus 2. So k times minus 3 plus 2. Sorry, I'm saying that wrong. 2 plus minus 3 should be equal to minus 2. All I'm doing here is plugging in the minus 3 into this function, and I'm setting it equal to minus 2. Wherever I had x, I'm putting in minus 3 in there. Okay, is that making sense to everybody? I just want to get a sense from the room now to see if people follow what I just did. All right, Charmaine, what do you think? Does that make sense? Okay. Angeli, how about you? Does that make sense? Okay, all right. So we just need to solve this now. Minus 2 plus 3 is minus 1. So minus 1k is equal to minus 2, which means that minus k is equal to minus 2, so k is equal to 2. Just divide both sides through by minus 1 now. K is equal to 2. That's all we need. That's it. That's all.